Hi you guys, here's your lesson for section 8.5, Law of Sines and Law of Cosines. Missy McCarthy, Okemos High School Math Instructor. In this lesson we're going to use the Law of Sines and the Law of Cosines to solve problems with triangles. It's going to be a little bit different than what we've been doing with sines and cosines and tangents up until this point. You'll see in a second. So up until this point, what we've done is focused on right triangles, and we've done the trigonometric values of acute angles. What we're going to do now is extend what we were doing with right triangles to any triangle, and therefore we need to be able to find trigonometric values of angles that are more than 90 degrees perhaps. So I want you to just try in your calculator. Your calculator will definitely find these values to find the tangent of 165 and the tangent of 94 degrees. So my calculator's in degree mode, and I'm going to do tangent of 165 degrees, and it gives me a negative number, negative 0.268 approximately. Negative 0.268. When you learn a little bit more trig, you'll understand why that value can be negative. Now let's find the sine of 94. So the sine of 94 is approximately 0.998. So that value is positive. So make sure that your calculator is in degree mode, because that's what's going to give you the right values, because we're using degrees for our angle measures. So that's just, a little quick thing on how to find the trig functions for angles that are not that are bigger than 90 degrees, that are obtuse. So now we're going to look at something called the law of sines. And again, we're applying trig functions now, or our attempt is to apply trig functions to triangles that are not just right triangles, but to any triangle. So we're going to use right triangles to get established here. So if I were to drop the altitude or the perpendicular from angle C to side C there, I really have two right triangles, angle B, side A, and I'm going to call the altitude H for height. And then I also have another right triangle right here with angle A with H and B. So I realize that H is across or opposite of angle B, and A is the hypotenuse of this smaller triangle. So I could do that the sine of angle B is equal to H over A. Likewise, for this triangle, if I look at angle A, H is opposite and B is the hypotenuse. So I could say the sine of angle A equals H over B. Now if we solve both of these for H, we get H is equal to A sine B, and this one we get H is equal to B sine A. Now because they're both equal to the height, which has the same measure, we can set them equal to each other. So we would get B sine A is equal to A times the sine of B, and if we divide both sides by AB, we end up with this nice ratio that the sine of A over A is equal to the sine of B over B. And now we have a way to relate the sides of the angles of any triangle, not just right triangles. If we were to take this drawing and draw the altitude, say from angle A perpendicular to the opposite side here, we would also get that this is equal to the sine of angle C over side C. And that's the law of sines. So here we go. It says for any triangle ABC with the side lengths small a, small b, and small c, the sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. And that's the law of sines. Now we need to note that the law of sines can only be used in certain instances. The law of sines can only be used in the case where you have two angles and a non-included side, or when you have two angles and an included side. And the last case where it might be used is if you have two sides and a non-included angle. So if that's the case, you can use the law of sines to find missing parts of your triangle. So let's do an example of this. All right, so we have a triangle here, and we need to find the measure of side FG. So FG is this side right here. So if we're finding FG, notice we have an angle angle side scenario here. So I'm going to do the side, I'm going to call this side actually H because it's across from little h. And that's the one we're looking for. And we have 40, well, we don't need to give it a name. Let's see, we can do the sine of H over the side that it's across from, which is FG, equals to the other angle we have is angle F. So sine of F, and we need the side across from F, which is side GH. Now notice, we know H, we know F, we know GH, we're trying to find FG. So then we would do the sine of 32 degrees over FG equals the sine of 39 degrees over 40, that's GH. We cross multiply for FG times the sine of 39 is equal to 40 times the sine of 32. And if we divide both sides by the sine of 39, we get FG is equal to 40 sine of 32 over sine of 39. So I'm just going to plug that into the calculator and get the value. 40 times the sine of 32, and then divide that by the sine of 39. Yep, so we get FG is 33.7 units. Okay, so that was using the law of sines. Now let's try another one. This time we're going to find the angle. Now in this case we still have the same drawing. We have angle, angle, side, and this time, oops, let's say we're looking for I guess this won't work. We'll just skip this example for now. We'll do a different one later in class. Alright, our next one is the law of cosines. So for this one, in any triangle ABC with the sides A, B, and C, you have three different relationships using the cosines. A squared is equal to B squared plus C squared minus 2BC cosine A. If you want to start with B squared, you got C squared and A squared here, minus 2. I would actually write these in alphabetical order. I would write AC times the cosine of B. And then C squared equals A squared plus B squared minus 2AB times the cosine of C. Notice the letter that you start with is the angle that you're looking for here. The letter that you start with matches that angle, and this letter matches that angle. So depending on what you're looking for or what information you have, you can choose a different one of these equations, but they all have the same formula, just plugging in different sides. You use law of sines, law of cosines in the case of a side angle side, or if you're given three sides. So two sides and an included angle, or three sides. So let's look at an example for law of cosines. Okay, so here for this one, we have a side angle side relationship. We know that angle Y is 110 degrees, and then we have two sides, and angle Y is included between the two sides. So we need to find XZ. So we're starting here. So if I were to write this out using law of cosines, I would write XZ squared is equal to 35 squared plus 30 squared, because those are the two sides we have, minus 2 times 35 times 30 times the cosine of 110 degrees. Okay, so we have everything we need to find XZ. So XZ squared equals, we need 35 squared, which is 1225. 30 squared is 900, minus 2 times 35 times 30, which is 70 times 30, which is 2,100 times the cosine of 110. So I'm going to just take that number, multiply by the cosine of 110. Okay, and then I'm going to do plus 1225 and plus 900. So XZ quantity squared is equal to 1406.76, and I'm approximating there. So now I take the square root of both sides. and we get xz is approximately 37.5 units. So we just used the law of cosines to find the missing side. Now, how did I know if I wanted to find xz? I had to use the angle that was across from it. And again, this was a side angle side scenario. Let's try one more. Okay, in this one it says find each angle, and this time we're looking for angle T. Now notice we're going to use the law of cosines because they gave us 3 sides. So we have side, 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 and that's the law of cosines. So if we're going to look for angle T, across from angle T is the 7, side RS, so that's what we have to start with. So we would do 7 squared equals 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of angle T. Again, we want to find angle T, so we start with the 7 squared because that's across from angle T. So we get 49 equals 169 plus 121 minus 2 times 13 times 11, oops, and that gives us 286 times the cosine of T. Now we have to solve for T. Do not do the 169 plus 121 minus 286. The 286 is not by itself. It's with the cosine T. So we do have to subtract 169 from both sides. And we do have to subtract 121 from both sides. But leave the other alone. So we've got 49 minus 169 minus 121. And that gives us negative 241 equals negative 286 times the cosine of T. Now at this point is when you divide by the negative 286. And then you have the cosine of T is equal to 241 over 286. Now to find an angle, we use the inverse trig function. So T is going to be equal to the inverse cosine of this ratio, 241 over 286. And I'm going to do inverse cosine of 241 divided by 286. And then if we do that, I get 32.6 degrees. 32.6 degrees. That's angle T using law of cosines. All right, here's our last example, I believe, is an application problem. So we have the drawing here. It says a sailing club has planned a triangular race course as shown in the diagram. How long is the leg of the race alongside BC? So we're looking for this side here. And then how many degrees must competitors turn at point C? So we're also looking for this angle. So my first question to you would be, are we going to use law of sines or law of cosines to start? Well, look at what they gave us. They gave us 2 sides and an included angle. So they gave us a side angle side. So that means we're going to use the law of cosines to start. Okay. Now first we're looking for this side. Oops. I should probably trace better than that. Side BC. So that means we start with BC squared and it's across from this angle. So we've got BC squared equals 3.1 squared plus 3.9 squared minus 2 times 3.1 times 3.9 times the cosine of 45. And I can plug all that in. 3.1 squared plus 3.9 squared minus 2 times 3.1 times 3.9 times the cosine of 45. And I put that all in at once. And it gave me BC squared is equal to 7.722 approximately. Now I have to take the square root of both sides. It's the square root of that answer. And it gets me 2.78 approximately. So this side is 2.78. Now that I know that that's 2.78, I am going to use the law of sines to find angle C here. I'm looking for angle C. That's what we're looking for now. I know the side that's across from it is 3.9. I also know that angle A is 45 and the side across from it is 2.78. So I'm going to use the law of sine now. I'm going to do sine of 45 over 2.78 equals the sine of angle C over 3.9. Now I'm going to cross multiply. I'm going to do that part right up here. I get 3.9 times the sine of 45 equals 2.78 times the sine of c. Divide both sides by 2.78. 3.9 sine of 45 divided by 2.78 equals the sine of c. And then I'm going to do the inverse sine. So the inverse sine of this whole thing, 3.9 sine of 45 over 2.78 is equal to angle C. So I'm going to type it in bits and pieces. I'm going to do 3.9 times the sine of 45, enter. Got a value. Now I'm going to divide that by 2.78. Enter. I got a value. Now I'm going to do the inverse sine of that. Inverse sine, second answer, enter, and we find out that angle C is approximately 82.7 degrees. Okay, rewatch any parts of the video that you need to make sure that you have a full understanding of law of sines and law of cosines. Also make sure that you memorize the law of sines and law of cosines equations. Those will be important. I'm not going to give those to you. If you have any questions, feel free to type them in the comment section of YouTube or bring them to class with you tomorrow. We'll do the lesson quiz and our worksheets tomorrow in class. See you then.